Hey everyone, welcome to SV DevOps. We're on quite a roll this year, 2021. We've been hitting every month. I'm just going to tell you a little bit about Lee. His career spanned a combination of AI and cloud. Prior to being the VP of Engineering at Pulumi, he was an entrepreneur in residence at the Allen Institute for Artificial Intelligence, and he's also a GM at Amazon for Route 53.
Cool, great. So thanks for having me. Going to talk about modern infrastructure as code. Going to talk a little bit about what Pulumi is, and then also talk about just the concept of infrastructure as code, and really talking about it from the perspective of software engineering practices, and how that all makes sense to fit together. So I'll start with just what is Pulumi. Pulumi is a infrastructure as code platform. We kind of are a cloud engineering platform. It's not just purely about infrastructure. We support any cloud architecture, and you get to use your familiar programming languages and tools. That's probably one of the biggest selling points or interesting points about what Pulumi really helps you do. And then, it's really for any cloud engineering organization. It's not just for, the infrastructure practitioner. It's for developers. It's for DevOps. It's for everyone on the team, including, people who are on the security side of things. Kind of like just talk a little bit about the motivation behind why it's important to think about Pulumi and just infrastructure in general, why we think about this as about software and about code. If you kind of think about, the very beginning of how people started building applications in cloud, I'm sure a lot of people are familiar with some of the tools at the bottom of the slide. It's, very much oriented around, individual VMs and these end-tier apps. And so, it made sense to use tools like Chef or Puppet or Ansible, where we're trying to configure a specific VM, or we're trying to, make a bunch of things kind of look the same. But it's kind of still in a very much, I'm sure people here are familiar with the, pets versus cattle, kind of still pets-ish. And then we kind of, we have this middle part of this slide, this V2 area, where, it's less monolithic. You might be using some combination of public-private, and there's more VMs containers, but it's really not taking advantage of kind of what you see in this last part of the slide, where if you really think about how applications are structured today, they're very dynamic, and a lot of the business logic is encoded in the edges of this graph, right? So a lot of kind of the actual application logic itself is encoded in how the infrastructure is put together and what lives on those edges between the various pieces of application infrastructure. And this is really where, having a software engineering approach makes a lot of sense. So, whether you're doing infrastructure or containers or serverless, like, you really want to take a software engineering approach to thinking through what it means to actually put together your infrastructure. And I'll talk a little bit about this in terms of, like, I think a lot of people who may have already heard about Pulumi kind of think about this in terms of, like, oh, cool, it's all just about using my favorite language. It's just about using, one of the languages listed here on this slide. But I think really, the important thing to think about when we talk about infrastructure as software is that it's not just about language familiarity. Language familiarity obviously is very helpful. It's great. It puts us into a familiar place where we know how to use this particular thing. But what it really does is it helps us collaborate across teams. So having some common language lets teams who aren't familiar with, for example, some kind of DSL, it lets them all use the same common language. Or in fact, in some cases, with Pulumi, we actually see teams use different languages, but they all program against the same Pulumi programming model. So one team will be using Python, another team will be using TypeScript, but they can actually interact because ultimately it's the same underlying state system that they're interacting with. In addition to that, you get increased productivity. So it's not just about, oh, I can use Node or whatever it is. If you think about kind of what we actually sit on top of, you get to sit on top of the entire ecosystem that a language represents. And that includes, things like IDEs, and when you with an IDE, you get all the things you get around, IntelliSense or autocompletion, right? You get all the communities around, how to use a specific language. Most importantly, you get package managers and reusable libraries. So instead of having to think about, hey, I built this library of things that abstracts away how my infrastructure works, how do I let other people use that? Well, if you're using an existing language like Node or Python or whatever, you get to take advantage of the existing ecosystem around package managers. So you can take that infrastructure code you wrote and vend it as an npm package or as a package in NuGet. And it's just there for anyone else to use. And it also helps increase quality because, again, we're dealing kind of from a software engineering perspective. It lets you use all the existing unit and integration testing frameworks you already know and love. So, for example, if you prefer to use NUnit or you use Mocha or whatever it is, you can use that existing unit testing framework with your infrastructure as software because it's just software. And of course, when you leverage those ecosystems and you leverage those tools, you get. I haven't even mentioned code coverage tools, linters, static analysis. All that is available to you when you think about using the language that you love and taking that approach with infrastructure as software. So I talked a little about some of the tools and don't have to talk too much more about this, but really kind of I think that's kind of the important thing when we talk about using languages. So software is all about abstractions. I talked a lot, so far I'm talking a lot about, hey, if we think about infrastructure as code as kind of software instead, right? As how do we use this in a software context? We have to start thinking about abstractions, right? How do we actually abstract away things like a VPC so that someone doesn't actually have to understand? If you think about like a VPC or something like that, someone has to understand like, well, what does it mean to construct a subnet and what are subnets and what are route tables and what are NAT gateways and what are internet gateways and how do those things all fit together? And a lot of times, depending on who's using the VPC, you may not need to understand any of that. And that's what software is great at. It helps us abstract away concepts that the stuff that we care about, we don't have to care about. We get to care about, and the stuff we don't care about is hidden under the hood. And so we have a couple libraries that actually we've built, but anyone can build these libraries on top of Pulumi, right? Pulumi exposes a programming model that lets you talk about infrastructure as software and ultimately lets you also abstract away infrastructure as a library or as a component. And I'll by the way, I'm going to walk through a bunch of the examples after I kind of explain a lot of these concepts. So we have a couple libraries we've already built out called Crosswalk, one for AWS and another one for Kubernetes. And both of these libraries are really oriented around helping people just get started quickly on these ecosystems, such that they don't have to know everything about AWS. They don't have to know everything about a VPC, or they don't have to know everything about how to start a ECS cluster, and really just get up and running in a few lines of code. And similarly, with Kubernetes, the same thing, where instead of having to understand everything about deployments and services and pods and how to put them all together, really providing some abstraction layers to help make that a lot easier around what does it really mean to deploy an application into a Kubernetes cluster. So kind of just, pause here for kind of an overview of or summary of kind of what we've talked about so far, where, if you think about infrastructure as code and kind of how can you actually take software engineering practices and use them, you can treat it the same way, where you keep your code in source control, you use whatever language you want, you can deploy it via CI/CD, and just have it all work the same way any other piece of software works. So let's walk through some of this. I think I've done too much talking at this point, so I'm going to walk through a couple slides real quick on just kind of like what things will look like, and then we'll do some live demos. So I've talked fairly abstractly about like infrastructure as software. So this might be the first slide. Hopefully people can see what I'm talking about here, where this is actual code that describes your infrastructure. So one thing I haven't really mentioned so far is that Pulumi is, it is still declarative in the way that you expect for a lot of other infrastructure as code solutions, where you declare what you want, and it's a desired state model. So it's, I guess, it's declarative from that perspective. It's obviously it's an imperative program, but it is declarative from a desired state model. So this program will generate a desired state, and Pulumi, the actual CLI and engine, will advance your infrastructure into that desired state. And so here you can see we import this AWS library, we set some variables, and then you can create a security group, you can create a server in this in EC2 instance in this case, and those take those variables as parameters in just normal TypeScript. And because it's just normal TypeScript or whatever language you choose, you can use all of the actual programming features you expect. And so you can have conditionals and loops, and really pretty much any language construct, functions, classes, what have you. And you can mix and match the providers of your choice, and instantiate those providers. So here in this example, there's a combination of using AWS and Kubernetes where you can create this bucket, but you can also pass the name of this bucket into this particular deployment within the cluster. So let me just show a quick demo. So I'll bring up my command line here, and I think I may have to make this a little bit bigger. Hopefully people can see this. And we'll make a directory. And we will run Pulumi new. And this will give us a few prompts. So we'll call this, and we'll give it a stack name, and we'll deploy into US+2. And so this will run npm install, which will install a bunch of npm dependencies that are needed. And then at the end of this, we're ready to have a project. So if I open this in Visual Studio Code, let me bump this up too. This starts off with a very simple program, and we can actually even run Pulumi up right here. So if I run Pulumi up right now, it'll run a preview and it'll propose what it's gonna build. So you can see here, this is the preview update. And it's going to say, oh, you're going to create a bucket, and you can say yes or no. I'm not going to do it right now. We can actually, just as an example, kind of show you that mix and match thing I talked about earlier and how easy it is to just bring in other providers. We can npm install a GitHub provider. And let's import that as well. And so we could do like I think I mentioned using loops earlier. So we could do something like this. And let's say, in our contrived example here, I'm going to create a bunch of milestones in a GitHub repo. So we could do. So you can see here immediately I'm getting that auto completion that I talked about earlier. And we'll name this. Let's call it something like this. And actually, I guess we'll want this to be, let's pad this. So again, you can use all the normal language features you expect. So we can have something like this, where we say, convert to a string, and then we pad left, is it pad start? Sorry. You can pad start, 2 with, zeros, right? And so now it's padded. So we'll call this like this. Again, relying on my auto completion here, I have a repository already called SV DevOps, and the title will be this milestone. So let me just real quick review what I just did. I made this for loop. I took this value and I used some standard, TypeScript functions against it. So it's converting that number to a string and then padding it with the zeros for up to 2 digits. And then this is the name of the resource within the Pulumi system. So this is how we track the name of resources within here. And then we're going to create this milestone inside the repository under Lee Zen DevOps with this milestone title. So let's run Pulumi up. And it should propose doing 2 things. It's going to propose creating this bucket, and it's going to also propose creating these 10 milestones in my repo. So let's say yes. Oh, and actually, I have a feeling this is going to fail. I just realized I don't think I have my GitHub credentials set up correctly in this environment. Oh, maybe I do. It seems to be doing it happily. So if we go to this browser I had open, if I go to, let's see, issues, milestones, you can see updated less than a minute ago, it just created all these milestones. And this is all, again, a desired state model. So if I were to add a due date, for example, and we made them all due, I don't know, like on April 1st, if I run Pulumi up, again, this is going to be, should basically either replace or update those milestones that already exist. So you can see here, it's saying, hey, I'm going to propose updating every single one of these milestones. In this case, it's going to update the due date. So let's say yes. And you can see it did not propose any updates or changes to my bucket object. So that bucket object is going to just, it's still there, but we don't have to do anything with it. And so here it's running this update. You can see it's updated those values. And so if I refresh here, you can see these are all due April 1st now after the update. So, very basic example, but hopefully gives you a flavor of some of what I'm talking about in terms of, getting to use the full power of the language that you already know, where, in the example I was showing just now, I got to use, loops. We can use conditionals. So for example, you could say if Pulumi so what's going to happen actually here, oops, what's going to happen here is if I run Pulumi up again, oops, what's going on? The terminal seems to be not responding. Oh. If we run Pulumi up again, it's actually going to propose deleting this bucket because we previously created the bucket, but in this current run that I'm running right now, I'm not in the production stack, and oh, sorry, I don't know how to write logic. If it's equal to production, do I create this bucket? So now it should actually propose deleting this bucket because the stack name that we were operating under is called dev. So this is not production. So you can see here it's going to delete this bucket. And if I run yes, it's going to delete the bucket. Okay, so let's move on and talk a little bit deeper about what it really means to use infrastructure as software. So I showed some fairly simple examples declaring things, but where things get really interesting is around reusability and having components. And so I'm going to walk through an example I already built around using components. And by the way, I'm going to gloss over this because I think just showing the component stuff will take a good amount of time, but you can also do unit testing in Pulumi as well. And so again, if we think about infrastructure as software, we want to do all the software engineering practices, right? Kind of as an engineering organization, as you have increasing levels of maturity around your engineering practices, you're going to want to do all the software engineering things to your infrastructure software. So you're going to want to do unit testing. You're going to want to do integration testing. You're going to want to spin up an ephemeral stack and do smoke tests against that, right? And so kind of all the software engineering practices that have come into existence because they are good for software, we're going to want to do them for infrastructure. Like there's a reason we came up with all these constructs for software, and infrastructure really should be no different. So let me bring up this component example, and I'll just walk through kind of what it is first at the very high level, and then we're going to dig into the code. So at a high level, what we're going to build is a GitHub webhook component. And if anyone's ever used GitHub webhooks, you'll know that GitHub allows us to define a bunch of events we want GitHub to fire webhooks against, or attach webhooks to rather, and then it fires those events against an API endpoint we define. And so an easy way to do this would be to define an API endpoint backed by API Gateway and Lambda, AWS Lambda, where we get to execute some function that takes the event GitHub has fired and then does something with that event. And so really we're talking about composing a couple different resources, right? We're talking about composing an API gateway, a Lambda function, and a GitHub webhook. And so kind of building on top of the thing we just showed earlier where, hey, let's mix AWS and GitHub together. We're gonna do the same thing here, but earlier it was contrived. I just like did some milestones and buckets. This is like actually for real and useful. And so let's kind of walk through some of this code. First, I have this GitHub webhook token. This is just a token that is defined in my stack configuration for the GitHub webhook, for GitHub, sorry, the GitHub provider. And we're going to use this token later on in our code. And so you can see here that providing the token into the webhook, we can basically use that for setting up our handler. And our handler, this handler is actually the webhook handler. This is the code so this is another interesting thing is we're inlining actual code we're going to run in AWS Lambda in our Pulumi program. So we're mixing both our application code and infrastructure together. And so this code is fairly simple. It says, this is the GitHub webhook request event. And we're going to construct a GitHub OctaKit. This is GitHub's API SDK. And so we'll take the SDK object and we'll have this issue event object. This is the actual data coming in from the event. And so if it's not equal to closed, so we're going to ignore it. Oh, by the way, I should mention what we're building. We're building a little bot that for any given issue will reopen the issue if it does not include a label called fixed. And so we only care about times when the issue is closed. So we'll only look at closed issues. So that's what we're doing here. And then later on, we also have this thing where we just check to see if the issue's labels include fixed. And if not, then we're going to reopen the issue. And so here we just use the underlying OctaKit SDK, and we'll call an update against this issue to set it to open. So fairly simple callback method. And a lot of the magic here is happening under the hood in this abstraction that I've created called GitHub webhook. So this is a class that I created. And if we go into the code for this class, you can see it's sitting here. This is a reusable component that you can imagine I could write a different webhook and it would have a different, set of code in the handler and it would do something different, right? And it could have completely different parameters, but ultimately it's going to do the same thing, which is hook up a GitHub repository webhook to a AWS API gateway endpoint backed by a Lambda function. And so here I define a couple interfaces around what the request and arguments are that I expect. And then the magic is in here. So in this constructor for this component resource, we first create a secret. And this is not a true secret, but just a random string. And this is because if you've used GitHub webhook before, you can have it pass as a parameter an additional hex value, basically, that acts as a signature for the event. So you can verify that you're only getting legitimate requests from GitHub itself and not from some random person hitting post requests or whatever against your API endpoint. And so the first block of this code is really just checking for the right data, making sure there's a request body, and then doing the little signature check. And assuming the signature check all checks out, then we can parse the body. And then here, this actually calls into the handler that we defined earlier. So that handler is provided as an argument to this component, and this component executes that handler. And so it passes back the token in case you want to use it. It also provides, the request information and everything else. And then that's that. So this is the actual, oh, by the way, I should have mentioned, this is the actual API gateway we're defining here. So here, this API gateway instantiation happens here. So this is creating an API gateway in AWS with a route where the route is just on the slash path. And then we're giving it a method post. And then this is the event handler where there's two event handlers. This is the event handler for the API gateway. This is what gets transformed into our Lambda function along with the code here. So this code is kind of, you can think we're passing that code into this particular callback. So that's how the API gateway and Lambda get constructed. And then we have those first two components, and then we have to hook that up to GitHub. And so here we call, we create this GitHub repository webhook where the configuration here points at the repository. It takes the events I configured. So here you can see when I call into this component, I say, hey, you know, this is the repository I want. These are the events I want. That's being passed in through here. And then finally, the configuration includes both the secret along with the actual API gateway URL that's defined. So you put all of this together and you end up with the infrastructure that's shown here, where if I go into the settings for this repository, you can see there's a webhook. And this is the, I executed this earlier. We can actually run Pulumi. Let's just bring up the Pulumi console. And so here you can see I have these resources. I have this Lambda function that got created as part of this. Let me open this. Oh, hold on. Just a sec. Let me just sign it off to the side here. All right. So, oops. So yeah, if I pop open this Lambda function, you can see I think I may have actually destroyed the stack earlier. Let me just run Pulumi up on this. This is the dangers of live demos, I guess. I think I may have actually removed some of the components, some of the underlying resources here. So let's run this. Oh, okay, yes. So let's try to push that. Oh, because I deleted it. Okay. Let's refresh. Okay, so some of these items got deleted because this is running in the dev. Yeah, I forgot. So in our dev environment, we actually at Pulumi we delete unused resources. So I think a lot of the stuff got deleted overnight. So let me just recreate some of this. I guess this is a good time while this runs to answer any questions. Okay, first question, is there a roadmap to provide Java SDK to use Pulumi? How to use Pulumi through Java or any JVM language? Yeah, so right now we don't have Java support in Pulumi. There's currently for the next couple quarters, no plans for Java in place. Definitely open to community contributions. We actually have a guide on how to add new languages to Pulumi. So can totally try if you want. But at the moment, for the next couple quarters in the short term, we don't have any plans for Java at the moment. We do plan to start adding more and more languages as a support for kind of our core code generation and multi-language support fall into place. So that's kind of the plan right now. What advantages does Pulumi have over Terraform? Yeah, I mean, I think hopefully just from what I'm showing you so far, you can kind of see some of the advantages I'm talking about, where like Terraform isn't really letting you use your infrastructure as software. It lets you kind of, be declarative about it, but really doesn't let you have the same kind of composability that I'm showing you here. There's a lot of other advantages around just our execution model and various things like that. But I think kind of the big one is treating everything as software, kind of everything I've talked about so far, right? Where we can take advantage of software engineering practices, whether that's, function, class encapsulation, or unit testing, or any other software engineering practices you would typically bring to bear. And then looks like someone else asked, does Pulumi Refresh get whole subscription resources? Not sure I quite understand the question. Do you mind clarifying? I guess if I'll try to interpret the question. If the question is, does it read the entire account or subscription in the case of Azure? The answer is no, it does. Pulumi Refresh doesn't read the entire account's resources. it's only trying to read the resources related to the stack that it's operating against. So in this case, it's only trying to, these were resources that were part of the stack. It's trying to read the current state of that resource to detect what drift there is, if any. And so it noticed, you can see that, hey, these things got deleted. And so now when I run up, it will go ahead and try to create those resources. Cool. Right. So, okay. So now we actually got everything recreated correctly. Now let's go back here. And hopefully this, again, this is the perils of live demoing. Hopefully this just works. So let's create a new issue. We'll call it a demo issue. Let's actually pop open the webhooks and let's refresh this. And so earlier I was trying to show this function, which didn't work because obviously I didn't have it ready to go. But now that I've run update correctly, this function you can see as we provisioned is hooked up to the API gateway. And if we look at the function code, okay, it won't let me it won't show me the code, but the code is actually what we defined in our own program code here. And so that's how all that's hooked up together. And so you can see the webhook is the webhook is also configured correctly. And great. Okay, cool. Okay. I wonder if this, okay, there's a weird bug I noticed, by the way, when I was playing with this earlier, where for whatever reason, GitHub initially wants to send this as form URL encoded, even though it's specified as JSON, but like the subsequent invocations all end up as JSON. So I don't know what's going on with that, but I think we have everything set up correctly. Let's try and see what happens when we invoke this code. So if we actually go and look at the Lambda, if we go look at the logs under monitoring, we can actually see this getting hit. And so earlier when I opened that issue, we should have, yep, we already had one invocation, and oh, this is the weird one from GitHub. Okay, let's do this again. So let's close this issue. Okay, this deliver. Webhooks. Okay, so great. So you can see that delivered correctly. And if we go here, hopefully we should see this here. Okay, so you can see it says ignoring non-close event. That was probably the first one. And then, oh, okay. And then this got reopened automatically. I wonder if my logs are slightly behind. Okay, not sure why the logs aren't showing up, but you can see, oh, here, okay. I think I see. Okay, I'm misreading my logs. So checking labels is actually what happens. This is correct. So sorry, everyone. If we look at the code, which I should have just done, in my handler, I check the labels and I reopen the event. And that's actually what happened here. We reopen the event. And then because we reopened the event, that actually fired another GitHub event against our handler. And that's the open event, which it's now ignoring. So that all makes sense. And then if we attach the fixed label, and we close this, then this should remain closed, hopefully. And if we look at our logs, I actually don't know if I have any logging for, okay, we should still see checking labels for this instance, which we do. But this time we don't reopen the event. We don't reopen the issue because we actually found the correct label. Cool. So that's all well and good. Let's go back to kind of what we were talking about here. So again, talking through kind of software engineering practices and applying software engineering to infrastructure. We've talked through now kind of the basics of just using software to provision infrastructure. We've talked through kind of using abstraction encapsulation methods you typically expect, using functions in classes to hide complexity. And you could totally imagine, by the way, with this thing I built, you could vend this as an NPM package, right? And someone else could go use it and they could just instantiate their own GitHub webhook and do whatever they want with it. And finally, we come to kind of when we think about software, like we don't always want to run everything in a CLI. You don't always want to run Pulumi up. And so here, I'm going to talk a little bit about Automation API SDK, which is also part of Pulumi. It's part of our SDK model, where you can actually talk about using Pulumi itself just in a program. And so, in this slide, I have an example where you import this automation library, and you can basically, program Pulumi to, select the stack just like you would on the CLI, set up config, and then ultimately run stack.up. And so here, this is the equivalent of running Pulumi up on the command line, except here we're doing it completely programmatically. And so you can do some really cool stuff with this, where you could do, integration testing or post-deployment testing, for example, where you have the stack, you run up, and then you run tests against it. So you can actually, after you hit the update, you can actually, make actual calls against that thing you just did. Or you can have all these kind of interesting self-service scenarios where you build an application that lets other people use Pulumi under the hood, use infrastructure under the hood that's provisioned dynamically based on actual requests. And so I have a quick demo, maybe. Let's see, what time is it? Okay, I probably won't go through the demo, but I'll describe kind of some of what's here, because I think just doing the demo alone will take probably 10 minutes. But here I have some more code to show, where this is an interesting example of mixing languages, right? You can totally imagine one team being more familiar with Python, a different team being more familiar with Node. In this example, I'm building an actual, again, using Lambda, an API gateway, to create an API called Website Builder. And the API has an endpoint called /builder, and anyone can hit that endpoint with a post request. And that post request will in turn execute this Pulumi program, which is written in Python. And that actually defines this create static website function, which creates a website, which creates an S3 bucket, which creates an index.html file in there with the contents of that post request. And so you can imagine empowering people within an organization to, stamp out stacks, using an online tool or something like that, and they can go stand up their own static websites, but it's all managed in code and all managed in a desired state method. So I realized kind of short on time, because I think we said we would stop after 40 minutes. So I'll stop there and try to answer as many questions as possible. All right, so I think there were already some questions kind of queued up while I was talking. Shri asks, in the Kubernetes community, there's a push toward using CRDs. Do you think there's any particular benefit in using Pulumi versus those CRDs? I think it's actually not really like an either or question in our case. Actually, Pulumi has a really cool integration for CRDs called CRD to Pulumi, where you can actually use CRDs in a typed way in Pulumi. And so you get all the benefits of those CRDs you wanted to use. Oh, I see. Sorry, I'm rereading the question now. Okay, so for cloud resource provisioning specifically, there I would say there is a benefit to using it in Pulumi versus directly in Kubernetes, mainly because at least in my mind, when you're dealing with those CRDs in your cluster, it's not managed in the same desired state way that you get with Pulumi, where you get to manage everything. You manage everything together. And so I would say, from that perspective, if you're talking about purely around CRDs for cloud resources, I would say in my mind, it makes more sense to provision them in Pulumi. But going back to what I was saying earlier, Pulumi actually has really good support for CRDs in general, where you get all the typing benefits of using something like Pulumi, where you don't get those type benefits in YAML, but still get to use CRDs. Is there any way to actually get state of all subscription resources? Yeah, this is a great question. So there's no kind of built-in mechanism in Pulumi to go ahead and read your entire account. What you could do is, in the case of something like AWS or Azure, run something like AWS config, and then compare that against what you have that's managed by Pulumi. Another thing you could do is Pulumi actually had, again, because we're just dealing with code, it's actually really easy to enforce things and also make things happen. So there's actually an example we have on the Pulumi website around automatically tagging all your resources, where you attach a piece of code as part of your Pulumi code, where you just have a piece of code that ensures that there's kind of two parts. One part is adding a tag to every single resource that gets created. You do that through a stack transformation, which is just code. You can also, on top of that, use policy as code to enforce the fact that every single resource should have a tag. And then kind of combining that with using something like AWS config, you can basically then do a diff between, what are all the resources you have and how many of them actually have the tags you expect. You could have a tag that's like managed by Pulumi, for example. Another person wants to ask, does Pulumi support VMware for environments not in the cloud? Yes, Pulumi supports many providers. If you go to pulumi.com, you can look at the list of cloud providers we support. One of them is vSphere, but obviously tons of providers, because really for us, it's not just about cloud providers who provide compute, right? So there's obviously we support a lot of them like Linode or DigitalOcean or AWS, but also just cloud providers you would use in any kind of infrastructure application. So by cloud provider here, we were referring really to SaaS providers in many cases as well. So for example, Okta, or I was showing earlier GitHub, or Cloudflare, and so just kind of anyone who might actually you might need to connect in with your infrastructure. We try to provide support for, and obviously also happy to take community contributions for new providers as well. Actually, a number of our providers had been built by the community, where someone wanted support for a particular provider. For example, NS1 was community contributed by, actually I think might have been by Grubhub. But yeah, lots of people contribute providers as well, since again, open source company, and so happy to have people contribute to our open source. Cool. Well, thanks for having me here. Hopefully this was interesting to learn about just using software engineering practices with infrastructure. If anyone has other questions, happy to stay a little bit longer and answer any of those questions.
Yeah, great. Yeah, let's see if we give folks a moment here if they want to ask another question. You can ask in the chat or the Q&A, I guess. And it looks like people want Java. That's a good sign, right? Well, cool. So I just had one question for you, and I think you kind of answered it, but I might have missed part of the answer, which is, if I wanted to take and investigate the resources I have available that I have running, let's say in AWS, and I want to just like export that, and then that way I don't have to like go do it manually myself. Like it'll just tell me. Is that something that I can do?
So you want to export what's in AWS?
Yeah. Like I just want to, yeah, like if like this say I've set up an app and I've got an AWS EC2 instance running and maybe a couple other resources. Is there a way to like investigate and see what's running and then like basically have it remember that?
Oh, I see. You can do what's called, there's kind of two ways to read state into Pulumi. One is called import and one is just called read, I guess. And so you can like read a resource into a program and then use that resource, as just another thing. But it is considered not managed by Pulumi, in the sense that like, if you were to delete the line of code that reads that resource in, nothing will happen to that resource. Separately, you could also choose to import that resource into your Pulumi program. And by import, what that means is it basically reads it and records it in the state file that we keep. And once it records it, then if you were to delete that line of code that represents that resource, then that resource would also subsequently be deleted And so that now it's being managed as part of your Pulumi program.
Got it.
Yeah. And then this is kind of related to, the question I answered earlier. Ian's asking, he wants to see infra that wasn't stood up by Pulumi to be flagged as rogue. Like I mentioned, there's today no built-in way in Pulumi to do that. You could easily, I think, write a program that does kind of what I described, where you would go read everything from your account, and then compare that against either some set of tags, or compare that against all the state that you have in Pulumi. And so you could do something like that to check, but there's no current built-in way in Pulumi to do that.
Okay.
So that's great feedback. It sounds like a couple people want that, so we can definitely take that as feedback for adding some kind of functionality for that.
Very cool. All right. Well, good. Well, thank you very much. I think we've exhausted the questions there. And is there maybe this is an opportunity for you to announce, like, is there any events or anything else that you're participating in that you want to let people know about? Like any, I don't know, you have your own meetups or anything like that that you guys do?
Let me think. So one thing, I guess, one thing definitely I think I will mention is if you enjoyed the kind of like live demoing coding stuff I just did, I do host a show on YouTube called Modern Infrastructure Wednesday, where I just go through various use cases of software engineering applied to infrastructure, the way we just talked about with this GitHub webhook example, or showing some of the in-depth automation examples as well, and really building stuff from the ground up in a live coding fashion. And so if that's interesting to folks, check it out on pulumi.tv. That's a fun way. And I see Wendy just dropped a link in chat as well for upcoming events that we have on our website as well.
All right, folks, thanks very much. Thanks for coming. Lee, thank you for your presentation.
Yeah, thank you. And one last quick thing is just we also have some t-shirts to give away to anyone who asked questions earlier.
Oh, great.
So we will make sure to contact you to get that figured out as well.
All right.
Awesome.
Hey,
thanks.
Yeah, thank you very much. And thanks, Wendy. Thanks, Lee. And we'll see you guys maybe in your, what's it called again? Modern Infrastructure Wednesdays?
Yeah, Modern Infrastructure Wednesday on Pulumi TV. And also, if you want like super friendly people in community Slack, you just go to slack.pulumi.com, and we're happy to help anyone there who has any questions.
Great. Cool. All right. Thanks a lot. Thanks, everyone. Have a good week.
Thanks very much.
See ya.